All right, let's get started. If you have not responded to on campus, please do that. Uh, and also, if you've made some generic comment, fix it. Okay. I am happy to see that you guys are trying to be positive during this, and I want to see more of it. Okay. We're almost there though. We got like 2 weeks, if that, of class, so stay strong for this. All right. Um, Couple things. The homework that was assigned last night that had been assigned last week. So I'm not gonna bother going over too many questions on that, but I do want you to recall just what the law of sines actually is. All right. So up on your screen, I have the law of sines, and that says that the sine of an angle, the sine of an angle divided by its opposite side length is going to be proportional to every other sine of an angle over its opposite side length. All right, that's what the law of sine says. That's it. Okay, and this is like the start of us solving triangles that aren't right triangles. Okay, so we've done a bunch of examples like this. If you're still unsure how to do that, I went over examples last lecture and the lecture before that, and you have IXL. All right, so you should be getting pretty constant feedback on that stuff. So I'm assuming that everyone is okay with that stuff. Um, if you're not, we can talk after class. Again, like I said, this is like the second part of class. The third part, that meeting on Teams, that's when you should be starting your homework and doing it in a way such that I can help you when you come across questions. Okay, so like let's set that expectation now for today, because what we're going to go over today is maybe a little bit more confusing than this stuff that you see on your screen, because there's a couple more moving parts to it. It's all set in stone. It's not like a super difficult thing, but there's more mix matching and solving type stuff. So there's more algebra based in it. Okay, so I'm assuming that people are going to come up with more questions. All right. So after this, and this lecture shouldn't take long, I would like everyone to be on Teams and actually starting their homework immediately so I can help people when they come across questions. All right. So today we're going to continue that theme of solving triangles that are not right triangles. Okay, so everything, uh, well, before the law of sines, we solved right triangles, right? So we're using SOHCAHTOA, we're using inverse trig, we're using the Pythagorean theorem, and given all those tools, we should be able to solve right triangles given a couple of sides or a couple angles. With the law of sines, uh, we're not dealing with right triangles, okay? And we have an angle, its opposite side length, and then one missing piece of another proportion. And then all we have to do is solve our proportion, and we're done. All right. Today, we're going to be doing kind of the same thing, but instead of the law of sines, we're dealing with the law of cosines. Okay, so I'm going to give people a minute to kind of write this down. This is super important. It's going to be super important to have in front of you. All right, and I'll kind of talk through it once people actually have it written down, and we can go through a couple of examples. All right. So hopefully you've had a second to write these down. This will I'll have this copy and pasted on each problem. But really, what this is saying is that the same rules apply for the law of sines. All right. So we're still dealing with angles and their opposite side lengths. All right. So angle A has opposite side length little a. Angle B has opposite side length little b, and angle C has opposite side length little c. Okay. Uh, so if we are solving for little a, right, the side length little a, we would set up the equation like so. Okay. So in order for this to work, we still have to know the side lengths b and c and the angle a. Right. So the only unknown should be the thing we're solving for. That's kind of the trick with all this. Is writing an equation such that the thing we're looking for is the only unknown in our equation, right? So if we're solving for like little b, we have to know little a, little c, and angle b. If we're solving for little c, we have to know little a, little b, and big C. Okay, and there is a pattern to it, and you should have noticed it kind of when you're writing down. But the thing over here doesn't show up in the equation at all on the right hand side. All right. And again, this will take practice, and we'll go through a couple of examples of this, but this entire thing should be in front of you while you're doing the homework tonight. And it will be in front of you while you're doing some of these examples. All right. So let's go through a couple. And there are kind of two different types. All right. So there is the SAS example, where we have a side, then an angle, and then another side. All right, so, or you could call it two sides and the interior angle. And we're trying to solve for the side opposite the angle. All right, so let me kind of draw what that actually means. All right, in this case, we are given big A, and we're trying to solve for little a, its opposite side. So kind of like all the other trick that we've been doing, the first step is to just define what we have and find what we're trying to, or label what we're actually trying to find. Okay, so we have big A and we need little a. So just by our equation, we need little b and little c, which we have, right? So if this angle is b, our little b is 10. If we have this big angle C, then our little c, our side length C, is 8. And then I would just, like, especially when you're starting to do this, I would explicitly state what you have. So you have big A, that angle. You have little b. You have little c. And you're trying to find little a. So if you go through each one of these equations, you know that we have to use the first one, because that's the only one with big A, little b, and little c in the equation on the right hand side, and we're trying to solve for little a. Okay, so we're using this equation. So if we plug all that stuff in, we have little a squared is equal to little b squared plus little c squared minus 2 times little b times little c times the cosine of big A. Okay, so before I go any further, are there any questions over how I got that set up? Instead of putting cosine A, when you put cosine of 60, yeah, that big A in there should be 60. And then Dominic, the cosine of big A is the same as the cosine of 60. Yeah, I just forgot to put 60 in there. All right. So after we do all that, then we do a little bit of simplifying, maybe a little bit of calculator work. I will say that even though you see 60 here, even though that's one of those values that I gave you a couple weeks ago, um, for your homework, all the directions just say to round to the nearest tenth. Okay. So you're not worried about rationalizing. You're not worried about um, making it a fraction, making it a simplified fraction. You're just worried about the decimal answer. Okay. So if we simplify a little bit, we have that a squared is equal to 100 plus 64. So I'm going to write this just as 1. Actually, I'll do it step by step. Then we can simplify a little bit more. Now, one thing that might get tricky here, uh, besides the setup, so there's kind of two tricky parts. Uh, where does 64 and 80 come from? 64 comes from 8 squared. And then 80 comes from 10 times 8. And then negative 160 comes from negative 2 times 80. And 164 comes from 100 plus 64. Okay, so there are kind of two tricky parts to these problems. One is the setup, just picking one of those three equations. The second one is kind of dealing with square roots, even though you really don't have to deal with them here. It's kind of a side thought, but because this a is squared, we have to take the square root of both sides. So when we do that, a will be equal to the square root of all that above. And then we have something that we can plug into our calculator and get an answer for. Okay, so there's a lot of like algebra here. Again, it's setting up the equation and then dealing with that square root. That should be the tricky parts. But once you get here, all you have to do is plug it into a calculator. You're not trying to rationalize. You're not trying to simplify fractions. You just plug this into a calculator and get an answer. Okay. So real quick, I want to pause for 10 to 15 seconds. Are there any questions about how I got here? Okay, then after we kind of solve for A or solve for our missing side, we type all that into a calculator. All right, so we go to our calculator. The first thing that we need to do is make sure we're in degrees. So go to your wrench icon, hit degrees, and then we're good. Okay, if you're on your TI-84 or TI-83, you go to the mode button. You scroll down to where it says radian or degree. You highlight degree and hit enter. Okay, and then everything else is pretty much the same. Okay, we want the square root of 164 minus 160 cosine of 60. Okay, so where did, whoops. There we go. I'm going to go down to this show keypad, get the square root, and then just start typing. Okay, for people with a graphing calculator, which is normally easier, but under the circumstances, I have to use Desmos. The square root is you hit the second button, and then down in that same row, there's x squared, and right above it in blue, there's a square root. So second x squared gives you the square root button. You want radian or degree, this will be in degrees. I'm pretty sure most of the homework is in degrees, and it's all in degrees. Okay, then our answer is 9.16515, etc. What is the website? This is Desmos. DESMOS. You might be able to see it. It's up here. Okay, now all of the directions for your homework will say to round to the nearest tenth. So this is really going to be 9.2. So our A side length will be 9.2 units long. So questions about how I got any of that, the setup, the answer, anything? So pretty much all we have to do is set up the problem correctly and then put it into the calculator. Yeah, pretty much. There's a little bit of algebra going around, but for the most part, it's setting up and then plugging into a calculator. All right, so I want to quickly kind of overview what we did there. First, okay, we're given a triangle that we don't know, that we don't know it's a right triangle or not. Okay, but we do have one angle, and we're trying to find its opposite side. So the first thing we do is just label what we have, and then from what we have, right? So we labeled everything. From what we had, we plug in to the correct formula. And then from the correct formula, we do a little bit of simplifying, right? So 10 squared is 100, 8 squared is 64, 10 times 8, that's 80. And then we have to take the square root of everything because we're solving for a squared right here instead of just a. Right, so we have to just solve for a instead of a squared. Then we plug it into our calculator and get an answer. Okay. One thing I do want to kind of highlight again, and I did this up front, but this is for a triangle with a side, then an angle, and then another side, right? So it's two sides and the interior angle. Right, so two sides and its interior angle. How do we know which ones are A, B, and C? Well, that's kind of an experience thing. It's really you have to label what you have and what you don't. Okay, so if you're trying to solve for the side opposite of an angle, right, that little side will go on the left. The other two sides will go inside or on the right hand side of the equation. Uh, yeah, so we'll go through more examples, but let's start here. When in life will this be used? Um, in all honesty, this is used quite a bit in anything architecture or anything without a right triangle. Okay, because it's this isn't a perfect triangle. It's not a right triangle. Okay, so in order to solve for missing angles or missing sides of different buildings or different measurements, this is going to be used. And there's a lot of computers that can do this too, but this is also used kind of later on when we get to calculus or kind of proof-based classes. Okay, this is really important. It's also just a kind of a neat exercise in what right triangles are all made up of. All right, so I want to do one more example or one more type of example, right? So this is side angle side in terms of what things we actually have on the triangle. Now I want to go over side, side, side. So now all we have are the three sides of a triangle. Okay, so now we don't have A, B, and C. We have Q, R, S. And instead of having an angle, we just have three side lengths. All right, so I'm going to give people just kind of a second to at least copy down this triangle, and then I'll start. All right, so the same thing applies to this problem. All right, the first thing we should do is to label what we have and what we need. All right, so first I'm going to kind of draw what we have. Right, so given this angle Q, we have its opposite side, which is 37. I'm also going to call this little q. Given this angle R, we have its opposite side, which is 23, which I'm going to call little r. And given this angle S, if we draw a line to the other side of the triangle, we have its opposite side, which I'm going to call little s. And then I'm going to explicitly label what we have. Okay, so we have the side length Q. We have the side length R. And we have the side length S. And we are trying to find angle R. Okay, and a type of question like this will actually show up on the ACT. All right, you'll be given these angles and you'll be given a couple of different choices of the equation that you would have to use. Okay, so even if you won't ever use this in real life or don't plan on doing architecture or anything like that, this does show up on the ACT. So it's very helpful to know, right? This is a point or two on the ACT that you could easily get so long as you know this type of stuff. Okay, so the first thing we know, or we're trying to find angle R. Okay, so we have to have cosine of angle R in our equation. And we know side R, so because we're using angle R, our side length R has to be on the left-hand side. Okay, so if you were trying to pick an equation from these three, we're going to pick this one right here, just based off of the color coordination I've done. All right, so that means that blue, our Q angle, our Q side, will be right here. Plus S squared minus 2 times 37 times 18 and then we have our equation set up. Okay, so I want to pause there real quick. Are there any questions about how I got that set up or anything on this page? Okay, so then again, like before, we just do a little bit of simplification. So 23 squared that's 529. How did you know which equation to use that the triangle didn't use A, B, or C variables? Could you just plug in the inverse cosine of R and solve it that way? Uh, so Nolan, for your question, that's what we're going to end up doing. But we have to do a little bit of algebra first. TJ, how did you know which equation to use if the triangle didn't use A, B, or C variables? Okay, so that's again that's part of the tricky part of these problems. Um, you have to ask yourself what you're looking for. All right, and we're looking for the measure of angle R. Okay, so that can be our only unknown in this equation. All right, and the only place that angles show up in these equations is on the right-hand side within the cosine. Okay, so that's kind of why I'm color coding it for you. Um, our only unknown can be this angle right here. And because that angle will be in that cosine, that means its opposite side length must be on the left-hand side. So those are kind of like your two anchors, if you want to call it that, of the equation. And then the other two sides just go on the right-hand side in the places of A and B. Okay, so kind of determine what you're looking for, and if it's an angle, put it in the cosine, and then that opposite side length has to go on the left-hand side of the equation, and then the other two sides can kind of go wherever, or in the places of A and B, at least for this bottom equation. All right, so when we simplified a little bit more, 37 squared is 1369. 18 squared is 324. 37 times 18 is 666. And then we still have the cosine of r on this side. Okay, now, again, what we're trying to find is that angle r. So we're trying to find this piece of the equation. So we have to get that piece of the equation by itself. So the first thing we have to do, well, let's simplify still just a little bit. So 529, 1369 plus 324 1693. And then negative 2 times 666 is negative 1332. Okay, so then for this equation, we have to subtract 1693 and then divide by negative 1332. So when we subtract 1693 from both sides, we get negative 1164. Is equal to negative 1332 times cosine of r. Then we divide by negative 1332. So I'm just going to leave this as a fraction. Okay, so when we do that, we get 1164 divided by 1332 is equal to cosine of r. Okay, so then we have something that we worked on a couple weeks ago with inverse trig. Okay, so we have our unknown inside a cosine. So in order to undo that cosine, we have to take the inverse cosine of both sides. So when we do that, we get cosine inverse of 1164 divided by 1332 is going to be equal to r. And then we can plug that into a calculator and get an answer. But for right now, I want to pause for a second. Are there any questions about how I got kind of those last 2 or 3 steps of the equation? So then, in order to get an actual number, so in order to get the actual angle, we go to our calculator and just type in exactly what I have up here. All right, so we want the inverse cosine of 1164 divided by 1332. Hit enter, and we get 29.08 degrees. Okay, so again, the directions for this would just would say to round to the nearest tenth. So our angle r is equal to 29.1 degrees. If you're using your TI-84, you hit second, then you hit the cosine button, and then do 1164 divided by 1332, and you get the same answer. So second cosine, and then type in 1164 divided by 1332, and you get 29.1. Or you get 29.088, but then you round. So again, let's kind of recap what we did. First thing you should always do is label what you have and what you're trying to find, which is what we did right here and on the triangle. Once you have that, you need to start to set up your equation. Okay, so I set up, because we're looking for we're looking for angle r, we have to have the cosine of r in our equation. That cosine of r determines where our side length little r goes, which is on the left hand side. And then q and r go in the place of a and b in our equation. Once we have that, we simplify a little bit, do a little bit of algebra, get 1164 divided by 1332 is equal to the cosine of r, and then we take the inverse cosine of both sides. So questions about that example? And I guess one thing I want to highlight again, this is when we have three sides. Okay, so three sides and we don't know it's a right angle. All right, so there are two different examples that we've gone over. We've gone over the three sides, which is where we're going to eventually have to use the inverse cosine. And then we went over two sides in the interior angle, where you're going to end up having to use the square root. Okay. So those are the two examples I have for you. I want to put this out there right now because I'd like you to start working on it, so I have a chance. You have a chance to work on it while I'm there. Your homework is R12. As of right now, this is due on Friday, but we'll see how people do with it. Okay, so I do want you to legitimately try it, especially for the next like 30 minutes or so. I will leave this stream open for the next like minute or two, and you can ask some general questions. Otherwise, again, I'd like you to go into Teams. I'll start a meeting, and you should start working while I'm there. And as you have questions, you can just ask. I know this is confusing at first, okay? But we need to at least try it, okay? So again, I'll leave this open for the next minute or two. Ask general questions here, and then I'll start a meeting on Teams, and you should start working there. I'll be on Teams for as long as the class ends, and if I need to go a little bit into actually, yeah, I can go into activity period. I don't actually have a class next, so I can be on there until 10:25 if you need me to. I will say this: you shouldn't like just try and guess on this stuff. Not like guess, but try and guess the equation. The more precise you are in doing every step that I've showed you, the less time that this is actually going to take. Okay. So it's okay to get a little bit frustrated for a little bit, but like take a step back, make sure you're doing every single step. right? And if there are no questions, I'll start a meeting on Teams. I'll end this, and I will see you there. Okay. So again, the idea is to work while I'm there to be able to help you. So I'll see you on Teams here in like a minute.